The countdown is on for NASA's next groundbreaking mission, currently being prepped in Titusville, Florida. This mission promises to deepen our understanding of the Sun and improve our ability to predict space weather, phenomena that can have serious effects on Earth. But here's where it gets controversial. How much can we really rely on these early warnings, and what are the implications for our technology-dependent society? Let's introduce the star of the show. The IMAP spacecraft, scheduled to launch no earlier than late September. IMAP will ride a SpaceX Falcon 9 rocket from NASA's Kennedy Space Center, specifically from the historic Pad 39A. Since arriving at the Astrotech facility in Titusville back in May, IMAP has been undergoing rigorous testing and preparation. It's now fueled and in the final stages before being enclosed in the SpaceX payload fairing. By mid-September, IMAP will be transported to meet its Falcon 9 rocket, and shortly after, it will be moved to the launch pad just days before liftoff. IMAP's mission is to study the solar wind and energetic ions streaming out from the Sun into the heliosphere, the vast bubble of charged particles that envelops our entire solar system. Kieran Hegarty, the IMAP program manager, explained to Florida Today that the spacecraft will focus on these solar winds, which are essentially space weather events that can impact Earth in significant ways. Understanding the heliosphere is crucial because it acts as a shield against cosmic radiation, but its boundaries and behavior are still not fully understood. IMAP will gather data using 10 advanced instruments on board, developed through a collaboration of 25 international partners. The spacecraft itself is organized into 6 bays housing 12 instrument sensors, plus one large sensor mounted on top. Though IMAP stands only about 3 feet tall and 8 feet wide, it weighs nearly 2,000 pounds, quite hefty for its size. Recently, media representatives were given an exclusive look inside the Astrotech facility, witnessing firsthand the spacecraft's meticulous preparation for launch. Once launched, IMAP will embark on a 108-day journey to the Earth-Sun Lagrange Point L1, a gravitationally stable spot about 1 million miles from Earth. From there, it will orbit the Sun in tandem with Earth, providing a unique vantage point for continuous solar observation. The data IMAP collects will be invaluable for predicting space weather events. Solar activity can disrupt satellites, endanger astronauts, and interfere with critical space technology. IMAP aims to provide up to 30 minutes of advance warning before harmful solar radiation reaches Earth. Potentially the most advanced alert system we've ever had. But IMAP isn't making this journey alone. It will share the ride to L1 with 2 other spacecraft, NOAA's SWFO-L1 and NASA's Carruthers Geocorona Observatory. In a nearby clean room at Astrotech, these 2 missions are also being readied for launch. The Carruthers Geocorona Observatory will map Earth's exosphere, the outermost layer of our atmosphere, by detecting ultraviolet light emitted from this region, known as the geocorona. Interestingly, research dating back to the Apollo 16 mission, led by Dr. Pat George Carruthers, revealed that Earth's exosphere extends as far as the Moon. Yet, the full extent of this atmospheric layer remains a mystery. Meanwhile, NOAA's SWFO-L1 mission will monitor space weather by observing charged particles emitted by the Sun, complementing IMAP's efforts. Robert Curbeam, CEO and President of Astrotech Space Operations, highlighted the significance of these preparations in an August 28 press release, noting that this launch marks the 551st spacecraft processed at Astrotech. The facility plays a vital role in readying these complex missions for their journey into space. Next on the agenda, transporting these spacecraft to NASA's Kennedy Space Center, Pad 39A, where the Space Coast community eagerly awaits the late September launch of these 3 sun-focused missions. This trio of spacecraft represents a major leap forward in our ability to monitor and understand the Sun's influence on our planet. But it also raises important questions. How prepared are we to act on these early warnings? And what might be the consequences if we underestimate the power of space weather? What do you think? Are these missions a game changer for space weather forecasting? Or is there more we need to consider? Share your thoughts and join the conversation below. Brooke Edwards is a space reporter for Florida Today. You can reach her at bedwards@floridatoday.com or follow her on X @BrookeOfStars.